So stoichiometry pretty much throws everything that we've learned so far into one big question. So I'm going to call this a continuum because depending on your question, you might want to start from the very start and work your way all the way to the end. Or you might be given something maybe already in moles and you can start at the mole number and go as far as you need to go. So this is going to help you out in the long run because if you're given something in mass and you want to find out the mass of something else, this is the order in which you'll do your math. You're going to have to take the mass of whatever you started with and convert it into its moles by using our molar mass triangle. Then once you have moles, we're going to do one of our mole ratios in order to convert it to the moles of some other compound. And then we can use the molar mass triangle once again in a different way in order to find the mass of our new substance. So this is kind of the order that we'll do all of our questions in. I've chosen to do question 7, which I think is the last one on the first side of the worksheet. So I haven't written out the question, I kind of just wrote out the balanced chemical reaction and summarized the information that was given to me. So I'm reacting 100 grams of aluminum oxide and I want to find out what mass of aluminum that's going to end up producing. So I have information about aluminum oxide, aluminum, nothing about oxygen, so honestly don't even worry about it. Don't even focus on that, just focus on the two things you know information for and what you're trying to find information for. So we're going to go through this continuum. We've started with mass, so we're going to start from the very start. So before we can pop into this triangle, we have to find the molar mass of aluminum oxide. So that was my step 1. I've gone to my periodic table. I know I have 2 aluminums, 3 oxygens. I found out the masses of both, did some multiplication, added them together, and I know the molar mass of aluminum oxide. Now I can use this number that I just found with the mass given to me in order to find out the moles of aluminum oxide. So it's division because mass is on top, molar mass is on the bottom. We end up dividing and finding 0.981 moles of aluminum oxide. So step 3 is our new step. That's our mole ratio, where we have 0.981 moles of aluminum oxide. And then I make a ratio based on what these things are balanced in the chemical reaction. So what we're trying to find goes on top. We're trying to find information about aluminum. It's balanced by 4, so it goes on top. What we already know about goes on the bottom, and it's balanced by 2. So we do 0.981 times 4 divided by 2. We'll end up getting 1.962 moles of aluminum. We're going to be going into our final step where we can take the moles of that and convert it into mass. So we need to find molar mass first to do that, which is nice, it's just aluminum, so it's literally what it is on the periodic table. And then all we have to do is multiply our 2 values. So the moles that we found from step 3, multiply it by the molar mass from the step we just went through, and we'll get to our final answer of 52.92 grams.